Thank you for joining me in this video covering the Chex application. You will not need your total station or tablet for this video, as I will be using the simulator to present the examples used. The Chex application can be found on the Icon Software's home screen within the Applications palette. If it does not appear here on your tablet, toggle it on through User Permissions. You may refer to Video 6 for a refresher on user permissions. Selecting the Chex icon takes us to the map view. If you do not see any points or lines on your map view to select, check that they are turned on through your Layer Manager. Refer to video 15 for a refresher on the Layer Manager. If no CSV or DXF files appear in your Layer Manager, ensure that they have been properly loaded to the job associated with the floor you are working on, within the project you are working on, and that you are currently working in the correct project and job. You may visit video 7 for a refresher on project setup and organization. The Chex application allows us to check exact dimensions from any point or line seen on the map view using the information we have loaded, or to check exact dimensions of field conditions by measuring points with the total station. In order to check dimensions of field conditions using the total station, we must complete a setup for the total station and know where it is in relation to the building and the control lines. You may visit video 16 for a refresher on setups. For us to complete a setup, we must power on both the total station and tablet and connect them through Bluetooth. You may refer to video 2 for a refresher on Bluetooth. For the purposes of this video, my simulator is set as if the total station has already completed a setup. At the map view, after opening Chex, in the upper right corner, we are first prompted to select or measure points and lines to check geometries. At this point, if we begin selecting either points or lines from the screen, the software will automatically begin giving us information related to the items we select. That information will be presented to you both on the map view and in the prompts in the upper right corner of the screen. Please note, if you cannot select lines from the map view, be sure you do not have your DXF loaded as a background image. See video 7, Project Setup and Organization, and video 11, Import tab for further instructions. Before I begin showing you the other ways of extracting dimensions, I'm going to cover the method that applies the most to the way we work and the way that information is sent to us on a regular basis. Afterwards, I'll return to the beginning and explain the rest. Normally, you are provided dimension plans on a plan grid from the VDC department that have dimensions to the control lines. In that scenario, you must flip between the pages on your iPad or computer to find low voltage, lighting, power, and so on. Once you find the page pertaining to the information you're looking for, you must find the specific component and then the control line it's dimensioned to. As we all know, sometimes field conditions don't permit us to use the control line used on the plans, and we must do the math to figure out the dimension to another line. Or the control line we need isn't laid out on the deck yet. Or any other number of reasons that we sometimes find ourselves impeded by the dimensions only being provided a certain way. The Chex application eliminates those problems. From the toolbox, I'm going to select the Point to Line tool. Notice that now the upper right prompt is asking me to select reference line or 2 points. I'll zoom in and select a line. A common mistake at this point is for people to start clicking points. First, you need to click the green check in the lower right corner to accept the line you selected. After that, you'll notice that the upper right prompt changed to ask me to select or measure point. Here's where the power of this tool really comes in. Notice that I can click any point on either side of the line, regardless of what kind of point it is. Also, I can select any line to measure from, not just control lines, but columns, walls, and any other line in the background. Compare this to using your iPad and having to switch pages to find the appropriate dimensions for the component type you're looking for, and only having those lines to measure from. You can rely on the information provided here because the dimensions provided on PlanGrid and the dimensions in the CSV and DXF files you have loaded come from the same place. You will of course need to have the latest files loaded for this to be accurate, but you should never be laying out with outdated files anyways. Now let's go over how this information is presented. To switch lines, open the toolbox and select Point to Line again. Notice that my screen clears and the prompt is asking for a line again. I'll select another line, click the green check, and select 1 point for now. The distance from the line to the point is displayed on the map view. Some versions of the software only display one dimension at a time. Others display every dimension you checked until you click the clear button, change operations, or exit the tool. But either way, the information is always presented in the upper right corner. The information for the last point selected is displayed in the upper right prompt. The upper left box contains the ID of the line you selected. The upper right box contains the elevation difference between the line and the point you selected. For our purposes, this is irrelevant. This happens when the points have elevations associated with them. The lower left box contains the station. The lower right box contains the offset, which is the only dimension we are concerned with. For our purposes and work methods, the only information you need when using this tool is the offset. Stations and offsets were covered in video 18, Layout Lines. Turning the prompt page shows us the data of the last point we selected. We have its ID, northing, easting, and elevation. Again, for the way we're using this program, you won't need any of that information. Now I'll quickly give you various examples using the Point to Line tool without reading my typed script. For whatever reason, if your total station doesn't have line of sight on the other side of shear wall rebars or column rebars, or if your batteries died and you find yourself in a position where you need to start laying out points with a tape measure, one person with this tablet could simply select the control lines, walk to the area they need to lay out, extract the information, and start sliding their tape measure out to hit multiple points, regardless of the point's type. Once they have their mark in this direction, they can switch lines and get the mark in the other direction and have all of the intersections for all the points they need to lay out. Another situation is you want to check to make sure the control lines on the deck are accurate. One of the quickest and easiest methods to do that is to take your tape measure and measure from the face of a column to the control line and make sure that dimension is accurate. Many times this will resolve discrepancies in control lines automatically. Another option is, if your layout team has already laid out the interior faces of the walls for the electrical room, one person can be using a tape measure to measure in the points, while the layout guy with the total station continues laying out in other areas on the deck. Just like with control lines, you can switch to the other wall and measure to get your intersections in the other direction. If you find your screen looking like mine and you have a lot of numbers that you start get confusing as to which means what, remember the only number we're concerned with is the offset, which can be found here. Or if you look at your screen, it'll be the line running from your line to your point. These numbers are the stations, and for our purposes doing this method, they don't matter. Now that you've seen how the point-to-line tool works, most of you will never need the other tools provided by the application. The point-to-line function by itself eliminates the need for dimension drawings on PlanGrid. A superintendent, even if they are not the employee using the total station daily, can use this application for dimensional purposes faster and more effectively than Bluebeam or PlanGrid once they understand how it works. If you wish, you can stop this video and go on to the next, which will be covering the sketching application. For those of you wishing to learn the other functions, please continue watching this video. For those of you continuing on, please note I cannot go into examples and scenarios for using every single aspect of this tool. If I did, this video would be too long. I will just be showing you what all the functions do and explaining the meaning of the data. For those of you who would like further training in the advanced use of these tools, contact me individually for one-on-one training. I'm going to reset the application to its beginning point by going to the home screen, selecting a different application, and then returning to the checks application. As I mentioned earlier, if I start selecting lines without opening any tools, the program will begin supplying me the related geometry of those lines. This is useful if you need to know specific aspects of the building, for example, a column's size, a wall's length, and so forth, as such. In the upper right corner, I'm given this information and even more. Let's go over what information is provided. The upper left box contains the identity of the line. The upper right box typically contains the layer the line is on. The middle left box contains the horizontal length or adjacent side if using the information for trigonometric functions. The middle right box contains the slope distance or hypotenuse for trig functions. The lower left box contains the elevation difference or opposite for trig functions. The lower right box contains the slope percentage or pitch, which can be converted to theta for trig functions. You may also know of these pieces of data as rise, run, slope, pitch, and so forth. They all mean the same thing regardless of how you use them and can be plugged into various formulae for calculation. To learn these formulae and how to use them, contact me individually for one-on-one training. Turning the prompt page displays more information. The upper left box contains the sum of the lengths of the lines selected measured with horizontal distances. The upper right box contains the sum of the lengths of the lines selected measured with slope distances if the lines have changes in elevation. The symbol next to the triangle means sum. The lower left box contains the azimuth of the line selected. If your DXFs were not drawn or rotated to state plane coordinates, these azimuths do not reflect degrees turned from true north. But if you're doing calculations longhand, they can still be used in relation to the building. The lower right box contains theta, or the angle between two lines selected when you have more than one line selected. On the next page, the upper left box will contain square footage measured with horizontal distances. The upper right box will contain square footage measured with slope distances. The middle left box contains the perimeter measured with horizontal distances. The middle right box contains the perimeter measured with slope distances. The lower left box contains volume measured with horizontal distances. The lower right box contains volume measured with slope distances. The last page contains data pertaining to the last item selected as before. Now, I have already selected a line. When I select a point after selecting a line, note that the program begins filling in the boxes of information that were empty, as well as graphically representing the information on the map view. Previously, we had no slope data, but because the point has an elevation associated with it, notice that the data changed as it shows us information between that point and the line I have selected. Flipping through the upper right pages shows you the data I previously defined. Notice that we still don't have volume data. I'll open the toolbox and select Block Volume. In the lower right box, I'll give it a depth and click the green check. Now my volume data appears. Now I'll click another point and notice how the software reacts. The upper right boxes always present the data related to the last point selected. Now I'll clear the screen and select 2 points instead of a line. Notice that just by clicking 2 points, I'm given the distance between those points. Then I'll select a third point. The information in the upper right boxes is the same information as with selecting a line first. It's the source geometry that I select that determines what information is provided and how. What I want you to understand is that you can select many forms of geometry, and that depending on the order of selection and what you select, you will receive geometrical information related to those items, and that the information will always be presented both on the map view and in the upper right boxes. Now, let's clear our screen and open the toolbox to select the upper left tool, which is Radial. Understand that the first point you select will become the vertex. Selecting one point after selecting your vertex will give you the normal information you would receive when just selecting 2 points. The difference now is that if I select a third point, I will be provided the information radially, and it's always sequential from the last point I select to the point before it. Watch this example as I describe what's happening. By selecting these 3 points in a radial mode, I'm given the lengths of the 2 sides and the deflection angle turn between them. If I select a fourth, that information is given to me as relates to the last 2 points selected. The deflection angle can be viewed here. What this means is that if I wanted the angle from this point to this one, I shouldn't have selected this one first. I'm going to clear the screen and show you an example. Select the vertex first, and then the 2 points you want, and then you'll have the interior angle for that one. I'm going to clear my screen and let's return to the toolbox. Notice that now the word radial has become the word polygonal. I'll select that. When I select multiple points now, the information will be provided as described, polygonal. At this point, I can return to the toolbox and select Block Volume, and apply a depth as before, which applies volumetric data to my dimensions. The next option in the toolbox is Save for Report. This takes a screenshot of the data on your screen that can be accessed by navigating through your Windows File Explorer. Selecting it allows me to give it a name. Clicking the green check saves it. Opening the File Explorer, I can navigate back one folder from Data, into Projects, the project I'm currently working in, go to Reports, and finally check Screenshots. This is where I'll find the picture that was shot. This is useful if you need to send a crew up to complete layout and you want to have the dimensions prepared for them. Extract your dimensions so that they display on the map view, save for report, and copy the screenshot image to their iPad so they can take it with them to the field. The last two options are undo and delete, which function the same as in the other applications. Finally, let's cover how the application functions when you're set up with your total station and wish to store points to check field dimensions. Once you've set up and referenced your control points, lock the total station on your prism or aim at the point you wish to measure if you're using reflectorless mode. Press Start, and when you're ready, click Store. Move to your next location to be measured and repeat the process. Notice as I begin moving, the software begins tracking my movements and a dimension line is following me, showing me how far from my first point I am. Once I press Store again, the dimension line stops following me. But if I press it a third time after moving away, it connects the measurements and provides the geometrical information related to the shots I measured. The information in the upper right corner is in the same format as before, and if I open the toolbox and apply a depth through block volume, it will react the same as well. This method is useful when you need to measure distances too far away to measure with the tape measure. It will also provide you with elevation differences, slopes, and other useful information. It is also a good way for checking angles, as in control lines. Typically, we are provided with control lines on a deck that are perpendicular or 90 degrees to each other. You can measure 3 points on the lines and see if the angle is true or not. When you're finished with this mode, the best practice would be to delete those points stored within checks if you're not planning to use them for any future work, so as to not clutter your layout map views with unnecessary points. Select Delete from the toolbox, select the points, and click the green check. As you can see, this application provides many different methods for extracting more dimensions than the average user in our trade would need. Point-to-line is going to be the most powerful and effective tool for us and should be fully understood to help speed up and simplify your work. This concludes the video covering the checks application. Please continue to the next video, which will be covering the sketching application.